If you told me a year ago that I would be making a YouTube video about rocks, I would have called you crazy, but here we are. Hello everybody and welcome to Project Launch Site. In this video, we're going to be talking about resources that can be found in space. These minerals can be taken from objects in space that are in use in Earth. Some of these minerals can be used to improve the quality of life for us Earthlings and help us tackle some big issues like climate change. Starting with everybody's favorite nightlight, the moon. Contrary to what you thought as a kid, the moon is not made of cheese. In fact, the moon is made of basically a lot of the same stuff that Earth is. Its crust was formed from cooled magma, and if you're a younger member of my audience, magma is like lava, but on the inside of a planet or a moon instead of the outside. It's used to form large land masses like islands and continents here on Earth. Now, with that explanation out of the way, let's go into a bit more specifics. According to NASA, in the deeper regions of the moon's crust contains very dense materials like pyroxene and olivine. Pyroxene and olivine are classified as silicates. Silicates have found use in CO2 scrubbing technology as well as the Earth's natural carbon silicate cycle. The cycle goes as follows. Carbon gets mixed into the air with clouds. Carbon in the air gets mixed with clouds and forming carbonic acid, or also known as acid rain. This acid rain will then rain down on silicate deposits, causing them to wash into the ocean by erosion in the water cycle. The eroded minerals along with the carbon will sink down to the bottom of the ocean and then be recombined into the Earth's crust to be formed into new minerals. The mining of this mineral on the moon can help us create more carbon technology to help curb the climate problem. Now, let's go into these specific crystals. Olivine crystals, also known as magnesium iron silicate, have some interesting properties and applications. For starters, it has a very high heat tolerance, meaning that it is common for it to be used in building materials for things like furnaces. Also, the magnesium in the crystal is an important component of medical treatments for conditions like diabetes, osteoporosis, and high blood pressure, to name a few. Pyroxene, on the other hand, contains a wide variety of minerals, but the one that I would like to focus in on is spodumene. Spodumene is a mineral capable of producing lithium, an important component of lithium-ion batteries. Next is the red planet itself, Mars. Mars is a rocky planet like Earth. From this similarity, we can safely hypothesize the minerals present in the planet's crust. To get the easy stuff out of the way, Mars also contains pyroxene and olivine, like the moon, due to the amount of volcanic activity that is present on the planet. It has polar ice caps that vary in size throughout the Martian year, and many mountains that cover the surface which can be used for mining operations in the future. The new Perseverance Mars rover has collected a lot of new data samples. One of the new technologies deployed by the rover is a device called the Scanning for Habitable Environments with Raman and Luminescence for Organics and Chemicals instrument, or SHERLOC for short. It is an instrument that allows to scan for organic minerals and things that would be present if there were life on the planet. Chlorine, phosphorus, and sulfur are very common on Mars and are in fact more common on Mars than they are on Earth. These minerals have a multitude of uses such as industrial materials, cleaning supplies, and medical treatments. This is good news because if we were going to build a research facility or some sort of colony on Mars, some of the materials we need in order to lay the foundations and build structures are already there. This would allow for spacecraft to only carry the necessary materials needed for construction. Before I close, I'd like to briefly mention other bodies in space. These bodies in particular would be comets and meteors. So comets are mainly made of ice and dust. So in the future, if we need another source of water, we can harvest comets for that. Although that would be very difficult since they are moving at very high speeds. And also, meteors are a form, have like different metals in them. So if necessary, we can go and mine meteors and asteroids in the asteroid belt, or meteors that are coming closer to that are deciding to leave the asteroid belt. In conclusion, what can we learn from this? So we learned that there are minerals that can be used to help us on Earth that are pretty close by, being minerals like pyroxene and olivine on the moon, as well as minerals that we can get from Mars that aren't as abundant on Earth, like chlorine, phosphorus, and sulfur. These minerals are out there. All we have to do is go and get them, but we have to develop technology in order to get them first. If you found this video interesting, don't forget to comment, like, subscribe, share the video, and be sure to see me in the next one. Have a good one.